In this lesson, I will explain to you confidence intervals for variances and standard deviations. Right, we have discussed variances and standard deviations many times, but here quickly I will explain to you. Suppose the average of my statistics class is 90% in midterm, right? And in final exam, suppose my average of the class drops to 40%. Now there is a big difference, big variance. If there is a big variance, then definitely we have to give some reasons why there is a variance. Maybe the topic was not clear, maybe the students did not attend the class. So what is the reason why it dropped from 90% to 40%? So variances and standard deviation should be small. The values should be close to mean. Then we will say these values are more favorable. If I will say the variance, same thing of midterm is, this is the average of my class is 90%, and in final exam the average of my statistics class is 80%. So this variance is acceptable, because we can say that midterm was based off only 4 chapters or 3 chapters, and this final exam was made from the whole book, complete book. All chapters were included. That is why it drops 10%. That is acceptable. So variance and standard deviation should be small. So what I have written here, one more example, when products that fit together, such as pipes, are manufactured, it is important to keep the variations of the diameters of the products as small as possible. Otherwise, they will not fit. See, if one pipe diameter is like this and other is this is small, they will not fit properly because there is a big variance and will have to be scrapped, right? So from this example, it is clear the variance should be small. And for these reasons, confidence intervals for variances and standard deviations are necessary. So we use chi-square distributions. When we will find out the confidence interval of variances and standard deviations, we use chi-square distributions. Chi-square must be used to calculate confidence intervals for the variances and standard deviations. Chi-square variable is similar to t variable. See, in t variable in the last lesson we had discussed, suppose this is the normal distribution. In t distribution, we make various graph, which is called the family of graph. So chi-square distribution is similar to the t variable in that its distribution is a family of curve based on the number of degrees of freedom. This is same whatever we had discussed in our t distribution. In chi distribution, we also make a family of graph, and the family of graph depends on the degrees of freedom, and degrees of freedom depend on sample size, right? Df, degrees of freedom, is equal to n minus 1, and we have discussed very well in our last lesson. The symbol for chi-square is, you can make like this. This is the symbol chi-square, Greek letter chi. It is pronounced by chi. Right, a chi-square, this is the important line, the last one. Chi-square variable cannot be negative, and the distribution are skewed towards right. This is one of the most important line. What is the meaning of it? See, in our normal distribution, the graph is like this. Both sides we have same amount of data. But in the case of chi-square, the graph is like this, right? Like this. It is here what it says, that negative and distributions are skewed to the right. If we have, suppose, 2 degrees of freedom, it is skewed like this. 4 is 4 degrees of freedom. As the degrees of freedom increases, when the degrees of freedom approaches to 100, chi-square distribution is similar to the normal distribution. So what I have written here, at about 100 degrees of freedom, the chi-square distribution becomes somewhat symmetric. Symmetric means mean, median, and mode lies at the center. almost more or less same amount of data we have here in symmetric, same amount of data here. So chi-square distribution normally is skewed towards right, like this. As the degrees of freedom increases, as about 100 degrees of freedom, chi-square distribution becomes somewhat symmetric, and area under the curve is 1 or 100%. So this is the example of a chi-square. See, when degrees of freedom is 1, it is the green one, right? It is here towards right. Degrees of freedom is 4. You can see the curve goes like this, and 10 and 15 means as the degrees of freedom increases, our skewness towards right decreases. Why? Because at approximately 100 degrees of freedom, our curve will be just like symmetric curve. So this is the important point, right? Here is find the area for x square right and x square left for a 90% confidence interval when n is equal to 25. This is again one of the most important point. Please do not use n in your calculations, n minus 1, because we are using degrees of freedom. In degrees of freedom we make different many curves, family of curves, right? So see here, it is 90% confidence, and we are going to find out our level, our range. Whatever we have discussed in the last lesson, we are going to discuss the range. But keep in mind, this is the important point, that this is skewed towards right. If I say normally what we do, we say okay, we are 90% confident, so this is 5% is doubt, half 5% of half is here, half is here. Same we see in the table. But in the case of chi-square, it is not equal on both sides. We use two different values. Why? Because both sides are not equal. It is skewed towards right. So I will show you the table, but here how I will see the table, I will show you 90%. So it means 1 minus 0.90, which is equal to 0.10, 10%. See, 90% we are confident, but 10% is the critical region. It means 5% here, 5% here divided by 2, which is equal to 0.05. So 0.05 we will see for the right side, but we will not see in the table 0.05 for the left side, because both sides are different. Here we have more data compared to right side. So what we have to do, whatever is here, confidence level minus 1 minus 0.90, 0.10 divided by 2, which is equal to 0.05. So 0.05 we will see for the right side, then 1 minus 0.05, whatever is our answer, is 0.95, we will see for the left side. I will show you, okay? Here, this is our table. Use the 0.95, because in the last slide, it was like this, right? Skewness. So here we have 0.05 for right side. This table has two parts. First here is whatever. If it is 0.10 is the critical region, divided by 2, which is 0.05, 0.05, 0.01, 0.005 here, and 1 minus 0.05, whatever is remaining, you have to see here, right? So our degrees of freedom are 24. So 24 is the degrees of freedom. 0.05 value is 36.415, and 1 minus 0.05, which is equal to 0.95. So this table has two parts, right? This is and this. For right side you have to see this right side table, for left side you have to see this left side table. So 0.95 value is 13.848, and see here I have written x square right, chi square right, and chi square left values. This is the formula we will use to in order to find out the confidence interval for variance, and this is for standard deviation. Whatever is your variance, take the square root, you will get the standard deviation. So n minus 1, what is n? Number of observations minus 1. This is the standard deviation, right, of a sample. And here is chi square left, chi square right values we have to put. Now I am going to solve one problem for you, example, then it will be much more clear to you. Find 95% confidence interval for the variance and standard deviation of a nicotine content of cigarettes manufactured if a sample of, this is N, 20 cigarettes has a standard deviation 1.6 milligram. See here, I said sample. On the basis of sample, we say 1.6 milligram, right? So on the basis of sample, we say, okay, for the population, it is also, the mean is, or standard deviation is also 1.6 milligram. So we have to solve it. We have to find out the range. To find chi-square, right, subtract 1 because the confidence level is 95%. So 1 minus 95% is 0.05. Whatever comes, this is our critical region, you have to divide it by 2. So this is 0.025. Right, and our sample is 20. We will not see 20 in our table. 20 minus 1, 19. So for 19 and right hand side you have to see 0.05 for the right side, and for the left side 1 minus 0.204 205, which is equal to 0.97. So this is our table. See, 19 is the degrees of freedom for the 0.025, because 5 was the critical region. 5 divided 0.05 divided by 2, 32.852 we will use for the right side, and 1 minus this, which is equal to 0.975, this figure we will use for the left side. So just put the values. See, is n minus 1 means 19, and then 1.6 is the standard deviations. Here is chi-square right value, chi-square left value. Simplify it. At the end we will take the square root. We are 95% confident that the true standard deviation is between 1.2 and 2.3 milligram. Sample was 1.6 milligram. On the basis of sample, we said we are 95% confident that the population standard deviation is also 1.6, right? But we had 5% doubt is the critical region. That is why we have to find out the range. So this is the formula calculation. We have to find out the range. So here I said it is 1.1 between 1.2 to 2.3 milligram for population.